this video, we're going to solve another optimization problem. The question states that we want to determine the point on the curve y equals 4 minus x squared closest to the origin. So like most optimization problems, the starting point, or a good place to start, would be to draw a picture. So in this case, I'm just going to draw this parabola, 4 minus x squared. So that's parabola, y-intercept of 4, opening down. Okay. And then I want to find the point on this curve which is closest to the origin. The origin is that point 0, 0. So there's some point on this curve. Call that point x, y. I don't know where it is, but the distance between the origin and that point will be the shortest or the closest. So it's a minimum distance. So like most optimization problems, or all optimization problems, the next step is to figure out what we're trying to maximize or minimize. We want the point closest to the curve, so we want to minimize this distance. So we need an equation for distance. Luckily from grade 10, we would have our distance equation, or the length of a line equation. I'm actually going to use an L for length instead of D for distance. You'll see why in a second. So the length of the line, or the distance between 2 points, is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. So we want to minimize this function. And again, we've got x's and y's. We just want one variable. So the points that we're going to use are these 2 points, 0, 0, and x and y. So the length is going to be equal to the square root of x1. Let's take this to be x1. So x minus 0 squared plus, that'd be y minus 0 squared. Simplifying that, you get square root of x squared plus y squared. Now again, I don't want both variables x and y, so I need to make a substitution, and the substitution just comes from that equation. That's going to go in for y, so the length is equal to the square root of x squared plus, and then I'm going to have 4 minus x squared, all squared. Right, that's just substituting 4 minus x squared in for y. So now I've got a function, or an equation, length, in terms of x. I don't know where this came from down here. Okay, so now in order to find the critical numbers, I'll take the derivative, set it equal to 0. Now notice that this is a big square root function, which was going to require using the chain rule. So as a little trick or a strategy to make our lives a little easier, I'm going to square both sides. So my function isn't L equals, it's L squared equals. To make this derivative a little easier, I will expand. So it's going to be 16 minus 8x squared plus x to the power of 4. Collecting like terms, we'll have x to the power of 4 minus 7x squared plus 16. So these L's should be squared. So now what I want to do is I want to take the derivative of L. I want dl by dx, and I'm going to set that equal to 0. Now notice this is L squared. But what I'm going to do is I'm going to take the derivative with respect to x of this, and take the derivative with respect to x of this, And now notice here I need to use implicit differentiation. So that's going to be 2L times dl by dt. Or not dt, sorry, dx. And then this I can just differentiate normally. So 4x cubed minus 14x. And now this I'm going to set equal to 0, which is going to make this whole thing equal to 0. So I end up with this equation here. That's a little bit easier to solve, or getting this derivative was a little bit easier than if we had tried using L equals the square root function. That we would have to use the chain rule. So by doing this implicitly, I avoided using the chain rule. And we're going to get the same answer either way. So now I just need to solve this. So I will factor out a 2x. So I get 2x squared minus 7. So that means 2x equals 0, or 2x squared minus 7 equals 0, which would mean x squared equals 7 over 2, which would mean x equals plus or minus the square root of 7 over 2. So now I've got three critical numbers. This one would be x equals 0. So therefore, critical numbers are we've got 0 and plus and minus square root of 7 over 2. Remember, the original question was determine the point on the curve closest. So that would be the one where the length or the distance is a minimum. In order to figure out what the minimum is, we need to do the first derivative test. So the first derivative test, there's no beginning point, right? Because this curve exists everywhere. The domain of the function was everything. So we set up our intervals. Zero to square root 7 over 2 and root 7 over 2 to infinity. This would be dl by dx. So we have to go back to the derivative function. So that'll be this one here. And remember, this is always going to be positive. So we're not really even going to worry about this. We're just looking at this thing here, which factored to this. So this is what we're looking at. So if you take a number here, sub it in to this equation, you would get a negative number. If you took a number here, subbed it in, you would get a positive number. Took a number between these two, you get a negative, and here you get a positive. So we have decreasing interval, increasing, decreasing, and increasing. So there was a min here, a max here, and a min here. So remember, the question was to figure out the closest point, which would be the minimum distance, which occurred twice. There was two minimum values, here and here, which would actually be the same distance, just kind of by symmetry, right? Whatever point on the x, it's going to be the same distance on the other side of the y-axis. So the minimum points, therefore, the minimum points, or the minimum, distances, distance will occur if x equals plus or minus root 7 over 2. And going back to the original question, we wanted to determine the point, so we need the y value as well. So remember, y equals 4 minus x squared. Just subbing in, we could sub in either point, or either x value. 4 minus 7 over 2, which would be equal to a half. So therefore, the closest points to the origin are, so we got the point root 7 over 2 1/2 and minus root 7 over 2 1/2, and that's going to be it's the same y value, because if you had subbed in a negative here, you would have got the same y value. So just going back and looking at it, that would be, so root 7 over 2 1/2, that's somewhere around here. So it makes sense that there's 2 points which are the same distance just by symmetry.